In 1.12, we're going to talk about percent change. So one formula that we're going to need for percent change, and I'll just give it to you now, is when we are talking about a percent change, we use our final price minus our initial price divided by our initial price. So finest minus initial price over initial price. And then we need to multiply that by 100%. And that will give us our percent change. So before I go into explaining one of the examples, let's just think about this. So basically what I'm doing, if I have a bigger final price, so let's say something increased by maybe $10, right? So we say that this price is bigger than our initial price. So when we divide this minus this, we'll get a positive number on top. We'll divide it by our initial price. So we'll get a positive number over here on the right, if the final price is higher than the initial. So that's a percent increase. But if we have a discount, like maybe say it's 10% off or something, so our final price is less than our initial price, then we get a negative number, right? Because we're subtracting by a bigger number. So if we get a negative number on the right, that's a decrease. Okay, so that's something important to think about when we're doing this. Okay, so 1.12, it says the ticket price for a one-day admission has steadily increased each year at many theme parks, including Disneyland in California. So it says use the line graph to answer the following questions. So it says by what percent did the ticket price increase from 2014, so that would be this one right here, to 2015, which is this one right here. Okay. Well, what we can do is we can just plug that into the formula, right? So this is our final price, that's what we ended at, and our initial price is $96. Okay, so I'll do 99 minus 96 over 96. So that's my final price minus my initial price over my initial price. Okay, so that should be 3 over 96, and 3 divided by 96 is, so we get 0.03125, right? And we change that into a percentage. So that's our second step. We're going to multiply it by 100%. So that equals 3.125%. Okay. So the next one says, use your answer from part A, so this increase, to guess or to forecast what the price is going to be in 2016. So basically what I'm thinking is that we increased by 3% of the price from here to here, right? About 3%. So let's increase this another 3%. So the way I can do that is let's multiply the $99 by 0.03125. So that'll just give us the amount of increase that we'll have in 1 year. And then let's add the $99 back in. Right? So we're just multiplying these two together, and then we're adding the $99 back in. So if we do that, we get 99 times 0.03125. So we get about $3.09. So we're going to add that $3.09 to 99. So 309. Oops. 309 plus 99, and that equals $102.09. Right? So that's what we would guess our price is going to be in 2016 if it follows this trend. Okay, and then the last question says, between 2000 and 2015, by what percent did the ticket increase? Okay, so we're going to look at 2015, which was $99, so that's our final. And our initial was the price in 2000, right? And the price in 2000, it looks like it was $43. Okay? So our initial is $43. Okay? And then the same steps that we've done before, we'll plug it into our formula. So we have 99 minus 43. So final minus initial over initial. Okay. And that equals 99 minus 43 divided by 43. We get 1.30. Okay? So basically what that's saying is if we convert that into a percentage, we get 130%. So we're saying that the ticket price increased by 130% over 15 years. All right. So now that I've shown you what that formula is, what it can do, what if we try something different? So this one says if we have $100 and we decrease it by 5%, well, we can do this in two different ways. So we know that a decrease in 5% means that it's going to be less than $100, right? So we can do it two ways. Our two-step approach is the way that I showed you on like the first page on part B. So we can multiply it by the actual percent and then subtract that from 100. Or we can also look at it is that a 5% discount is the same thing as something being 95% of the price, right? So you're just subtracting that 5% off of 100% of the price. And then we can just multiply 100 by 95% and get $95. Okay. So we could also do that with addition as well, right? If we are increasing in price, so if we have a 5% increase in price, we can either do this and then just add it instead, or we could say that a 5% increase in price means that the item just turns into 105% of the price. Right, so instead of a 95 here, we would have 100 or 1.05, right, which would be 105%. Okay. Okay. So if we want to find the multiplier of some numbers, this is going to be like our one-step process. So as an example, if I had a decrease or a discount of 5%, my multiplier here would be 0.95. Okay. So if I have an increase of 22%. What I'm going to say is that if you ever have an increase, all you need to do is just convert this into a decimal. So you just need to convert this into a decimal. And then just add 1. Then add 1. Okay? So what that's basically saying is that you're converting this increase into a decimal, and then you're just adding 100%. So that's just the price of the item. Okay? So it'd change into 0.22, then you add 1, so we get our multiplier is 1.22. Right? So this 1.22 is just like this one-step process up here. Okay? And then similarly, if you have a decrease, what you're going to do is you're going to change it into a decimal. And then instead of doing that decimal and adding it to 1, we're going to do 1 minus that decimal. So I'm going to have 1 minus 0.22. And if we do that, 1 minus 0.22, we will get 0.78. So our multiplier here is 0.78. So basically what that's saying is if you have a 22% discount, that's 78% of the price. And I'm going to omit doing this percent increase and percent decrease down here because that's just what I showed you up here. Okay? All right. So let's try another example. So this example says, a salesman starts the year with 200 clients and ends up with 260. So by what percent did his sales base or his client base increase? So we know that we started with 200 clients, so that's our initial. We ended with 260, that's our final. So it says by what percent did it increase? Well, we just plug it into the formula, right? So 260 minus 200 over 200. So final minus initial over initial equals, so 60 divided by 200, and then multiply that by 100%, we get a 30% increase. Okay? And then we can also do it again, but this time we're going to have a larger client base, right? So our initial, we start with 1,000, we end with 1,060. So final minus initial over initial. So we'll have 60 divided by 1,000, change that into a percent. So we get 6% increase this time. So we get a 6% increase. So this one says, notice that the quantity 60 is relative to the initial number of clients, right? So they both increased by 60 clients, but it's more important for the person with a lot less clients because it's a bigger percent increase, right? So that's kind of what we talked before, which is why I like percentages over fractions, right? So it puts it in perspective. So this is a bigger gain for this person in terms of percentages versus this one. So the way you could think about it, if you want it as like a real world example, is that this one right here, this could be like maybe a small business. Your business, if you buy stuff at some small business, right, it's going to be worth more to that owner than some place like Walmart, right? Because Walmart has millions of people that buy there, whereas, you know, a small business owner maybe only has 200 or maybe 1,000 people, or, you know, something really small compared to millions of people that buy there. Okay. All right. Let's go to the next page. So the next page says, interpret each multiplier as a percent change. So I know we're just going to work this backwards, right? So if I have 1.37, I know that this is going to be greater than 1. And since it's greater than 1, I know that it's going to be an increase. Okay. So when I did changing a percentage increase to a multiplier, I added 1. So to go backwards, what I'm going to do is subtract 1 here, and then multiply by 100%. Right? So we subtract 1, we get 30.37. Multiply it by 100, we get 37%. Right? Now for a decrease, what we're going to do, I know that this is less than 1, so it's a decrease. So what I'm saying is this is 51% of the price. So if we can think about that, what we need to do is we're going to do 1 minus that decrease, or minus that what the price is now, right? So we have 1 minus that, we get 0.49, and then we multiply that by 100%. Right? So we get 49%. So all we're doing is just working it in reverse. So instead of having the percent change, we need to find the percent change. Okay? So basically what this is in words is it's 51% of the price. So that means you're just getting a 49% discount. Okay? Okay, let's try a word problem now. So the word problem says, husband and wife are working together to lose weight. After the first week, they weigh in and compare their results. So the first thing we're going to do is fill in the table. And then we'll answer some questions. So the husband starts at 380 pounds and he ends at 366. So how many pounds did he lose? Well, 380 minus 366, we should get 14. Okay. And then the same thing with the wife. She should have 10 pounds lost, 200 minus 190. And then percentage-wise, well, our starting weight is our initial and our ending weight is our final, right? So for the husband, we'll have 366 minus 380 over 380, right? So that'll be the husband's, and then we can change that into a percentage. And then for the wife, we'll have 190 minus 200 over 200, right? And then change that into a percentage. So 366 minus 380. And if we see the top here, this top and this top, they're just negatives of how many pounds they lost, right? So this is just a negative 14 on top, and this is a negative 10 on top. So 14 divided by 380, we get a negative or I guess I'll change it into a percentage. So we get negative 3.68%. And for the wife, we get negative 5%, right? Okay, so now that we've done that, now we can answer the questions, right? So it says use the information from the table and circle all the following that are true. So A, the husband lost 4 pounds, right? So he definitely lost 4 more pounds than his wife, so A is true. The wife lost a higher percent of her weight. Yep, that's true. She lost 5%. The wife's new weight is 5%, 95% of what it originally was, right? So if we look at this, we could say that 95%, well, what is 200 multiplied by 95%? So 200 multiplied by 95%, right? That's 190. So you can just easily check that by multiplying 95% to 200. Or you can just notice that 5% discount is the same thing as 95%, right? So C is true. And then the last one says the wife's starting weight was 5% more than her ending weight. So the way we could look at this is we have a 5% increase for 190. So if I do 190 multiplied by 1.05, so that's just our 5% increase. If I do that, we get 199.5, and that's not the same as her starting weight, right? So it's not 5% more than her ending weight. So D is not true. Okay. Alright, so let's try the next page. So the next page says, the price of an item of an online auction goes from $200 to $400. So circle each of the following that are true. So there was a 100% increase in price. So if we look at this, we have our final and our initial. So we can do final minus initial over initial. Right? So you have 400 minus 200 over 200. And we should get 1, right? So we get 200 over 200. So if we change that into a percentage, we get 100%, right? So there was a 100% increase in price. Can we say the new price is double the initial price? Well, yeah, if we just multiply that by 2, we get the new price. Yep. Was there a 200% increase in price? Well, if there was a 100% increase, there can't be a 200% increase, right? That's not true. So is the new price 200% of the original price? So that one, I will let you. That's going to be an exercise for you. I'll leave that one for you. So I'll let you think about that. Is the new price 200% of the original price? And if you have any questions on that as far as the answer, you can always look in your book as well. Okay. Okay. So let's move on to this example here. So this will be our last example. So this one says a college raises its tuition each year by the amount noted in the table. Okay. So it says find the overall percent increase from 2012 to 2016. So this one is going to be a little bit more complicated, right? And the reason being is we have some price. So let's just say in 2011, and I'm just going to write in 2011, we have $100 for tuition, okay? And I just like using a real example, and I think 100 is nice because we can always just say that's a percentage instead to find the percent increase, okay? So we're going to start with $100, and we're going to increase that by 8%, right? So if I have $100, increase it by 8%, we'll get $108, right? And then we're increasing that by another 5%. So I'm going to multiply this by 1.05. So that's our 5% increase. So if I do that, the price here, so after that increase, is $113.40. Right? And now going from this step to this step, I need to multiply this. So we keep increasing in price, right? So we have 113 multiplied by 1.09. So we get $123.61. We're going to multiply that by 13% increase, which is 1.13 as a multiplier. We get $139.67. And we're going to multiply that by a 7% increase here. So it should be 1.07. So we end up with $149.45. Okay. So we could just say, instead of having this dollars now, we can just say this was 100%. Right? So our increase here is 149.45%. Okay? So the overall increase is 149.25%. Now some of you might be wondering, well, instead of just multiplying all those all the time, why can't we just add all the percents in together and then just add that onto, or multiply it by 100%? So the reason you're multiplying here rather than just adding all these together is because the first one's fine, right? So we just multiply by 1.08 to get there. But then you're multiplying this one, you're multiplying $108 by that 5% increase. Whereas if you just added them together, you would just be multiplying this 100% by 5%, right? So that 5% increase. But we're not increasing 100% of the price by 5%. We're increasing 108% by 5%, right? So this number down here is actually going to be greater than just adding all these up and multiplying that by 100%. Okay? So adding the percent change will not result in the correct percent change because you are using the multipliers on the previous year's price. So you're using the multipliers on the previous year's price. Okay.